Hi everyone. We've got our last lesson here in chapter 11. And so like before, you know the drill. We're going to take notes right along with the screencast here as we're learning. So we wrap up this chapter all about volume. And volume has to do with how much something can hold in a three-dimensional object. So your learning target today is to correctly calculate the volume of a rectangular prism, triangular prism, and cylinder, and I think you'll find this to be a lot easier than the surface area problem. So first thing I want you to do after you've got the heading up there, 11.6 volume, is write the word volume as a vocab word. You're going to have a couple bullet points coming off this. First and foremost, what I just said, volume is the three-dimensional space inside. So if we're talking about the volume of the Kleenex box, it's how much space there is inside of that Kleenex box. Because it's three-dimensional, when you finish this work, second bullet point, your units are going to be to the third power, or we say cubed, right? So if it's centimeters, we're going to have centimeters cubed. If it's meters, we're going to have meters cubed, etc. So that's how your labeling works. Compare that with our area before. Area was a flat representation, so its units were to the second power, or squared. The third thing we're going to put down, the third and final thing for volume, is the generic formula for volume. Now this is helpful, and you may remember this from when we did some MCA review. It's helpful, but it's not really helpful. We're going to have a lot more specifics, formulas for each one of our three prisms. So it's capital B times H, and the capital B stands for area of the base. And then of course you know our H is just the height of the prism. Right, and then for the area of the base, just make a note that this will be different for every different shape. So I'm going to say it's going to change each time. Rectangular prism, you got the base of a rectangle. Triangular prism, it's a triangle. So yeah, that's good, but we're going to be a lot more specific when we get to the individual shapes. So we'll start from the easiest one and go into the hardest one. The easiest one actually is a review from what you did in 6th grade. So make a heading there that says rectangular prisms. And then just draw a picture of a rectangular prism. And you got your base, and then make your lateral edges going backwards. We're going to say that this specific rectangular prism is 10 feet long by 8 feet with a height of 2 feet. So I did that kind of quick here. So our formula, of course, is area of base times height. And the way really for rectangular prism, if you can just take this and draw an arrow down, our formula that we're really going to use is length times width times height, because the base of a rectangular prism, a rectangle, is just length times width. And then like highlight that or put a box around it. That's the formula that we really want for rectangular prism. This is an easy formula to work with. So length on this one, and technically it doesn't even matter, is 8. Our width is 10. Our height is 2. Of course that can be in any order because we're multiplying. So that's really 80 times 2, which is 160. And when you look at here, we're dealing with feet, and so you say 160 feet cubed, or feet to the third power. And that is it for rectangular prism. It is one of the easiest things to do. Length times width times height. Done. Okay, advancing out, getting a little more difficult now. Next one, triangular prism. So make a heading below that that says triangular prism. And like we talked about with the surface areas for triangular prisms, these can be a little bit tricky because we've got the three different types of triangles. So we're going to do a right triangle right now. So draw a picture of a right triangle. And then from each of those, make lateral edges. Go back. That one should be dotted back there. And we're going to say that this has 4 inches by 3 inches. For the hypotenuse, I'm going to come up here and call that 5 inches. And then I'm going to go 10 inches for the height of the prism there. So we should mark the right angle. So the formula, again, is the capital B times H. Now for the triangular prism, come down here, like we did last time. The base of a triangular prism is a triangle, and so the formula for the triangle is base times height divided by 2 times H. Now here's the tricky part, okay? Everybody listening now? What we want to differentiate here is that this H and this H are not the same H, right? And you might want to draw a little arrow to this one and say, that's the height of the prism. And then this H over here, that's the height of the triangle. They're very different things. So watch how that works as we go into this example and how this is, and then put a big highlight or a circle or something around. This is the formula that we want for our triangular prism. The height of the triangle is 3. The height of the prism is 10, right? And you do not want to get those two mixed up. So here's how we go. So for the triangle itself, the base is 4, right? Base of the triangle. The height of that triangle is 3, and then we divide that by 2, and then we multiply that whole thing by 10. So notice we're not using all the numbers. This 5, not used at all in volume. It's the hypotenuse of the right triangle. We don't care about that 5. So when we do a little PEMDAS here, 4 times 3 is 12. This is really 12 divided by 2 times 10. That'd be 6 times 10. And that's going to be 60. And then we're talking about inches here, so 60 inches cubed, 60 inches to the 3rd power. So look at the work that I've shown here. That's what I want to see you do as well. Don't try to skip steps. Show this line, show the simplifying, and then get down here with your answer and your label to finish the triangular prism. So a little bit longer than the rectangular prism. Still not that difficult. Last one, cylinder. Make a heading there that says cylinders. And then draw a picture of a cylinder. Let's say that this cylinder, has a height of 8 meters, top to bottom, and this has a radius of 3 meters. Right, same formula. Volume equals area of the base times height of the prism, or cylinder in this case. The base is a circle. We've been working on this formula with our surface area work as well. So draw an arrow down to cylinder. The area of a circle is pi times radius squared times the height of the prism. And you may remember we reviewed this one before MCA. So that's the formula that we're going to use right there. Pi r squared times h. Pretty straightforward stuff. So here's how it works. We're going to go 3.14 times our radius is 3 squared times our height is 8. The one little tricky thing about this formula is make sure you follow the order of operations. So here we're going exponents before multiplying. 3 to the 2nd power is 9. So we're going to take 3.14 times 9 times 8. And I'm just going to do that here in my calculator. 3.14 times 9 times 8. And I get 226.08. We're talking about meters here, so meters cubed. And that's our final answer. Done. That's cylinders. Okay? So that's the 3 things today. Remember that volume tells you how much can go inside, right? How much space you have inside that object. So out of the 3 of these, I'm going to go backwards and I'll come back to this here. I think the one that I've seen people make the most mistake on out of these 3 things, it's not the rectangular prism, not the cylinder, but the triangular prism. And really, the mistake people make is right there. Just finding the area of the right triangle, knowing what's the base, knowing what's the height, and then differentiating that from the height of the actual prism. Remember that when you're looking at a triangle, the base and the height have to be perpendicular. They have to make that 90-degree angle. All right, what I'm going to have you do right now is draw a line right where you've been taking notes. And then I want you to letter A and letter B, and I'm going to have you try these 2 problems, letter A and letter B. We're going to copy them down right now, and then you're going to try them and see how we're doing here. So letter A, I want you to make a cylinder. Make the cylinder that is 5 yards tall and has a radius of 2 yards. And you're going to find the volume. For letter B, I'm going to have you make a triangular prism. We're going to do an isosceles triangular prism. So we're going to have this side be 4 inches, this side be 4 inches. It's going to go back. And it's going to have a height of 12 inches. And then our hypotenuse of this right triangle is going to be 6 inches. So find the volume for both of these topics. Team up with your table partner. Pause the video. Okay, let's check in and see how you did. For the cylinder up here, you should have taken our volume formula, which is pi times radius squared times height, gone pi times 2 squared times 5, 2 squared is 4, so really you're taking pi times 4 times 5, that gives you 62.8 yards cubed. So if you made a mistake there, go back, fix it, so that you get 62.8. The triangular prism, you should have taken base times height divided by 2. This is an isosceles right triangle, the base and the height are both 4, so 4 times 4 divided by 2. Times the height of the prism, which is 12. 6, kind of like our other example, not used, it's the hypotenuse. So 4 times 4 is 16, half of 16 is 8. 8 times 12, 96 inches cubed. Right? And this is the minimum amount of work I want to see when you're doing these. I think on a test or a quiz or something like that, I think these are 3 to 4 points. I think this one would be 3, 2 for the work, 1 for the answer. Actually, it's 4 because there's another one for the label. This one's got 2 or 3 points. With the work, answer, and the label to it too. So make sure you're being very thorough and showing your work on there. Alright, we're going to break out and do some classwork and do some more practice on these things. You guys have a good rest of your day, and this video is posted on Moodle if you need to see it again. Alright, thanks you guys.